Hi class, we're now going to look at protons, neutrons, and electrons. So an atom, if you break the atom open, think of like an eggshell, it consists of a nucleus that is located in the center of the atom. That's the most concentrated part that contains protons and neutrons and represents most of the mass of the atom. Electrons occupy a large empty space around. So again, that football stadium, the golf ball or ping pong in the middle of the football field, and everything else after that is considered where the electrons would be, all the way up into the end of the parking lot. It's a large volume of pretty much nothingness except for where the electrons are found. So a mass of an atom. In an atom, the protons and neutrons that make up almost all of the mass are packed in the tiny volume of the nucleus. So if you break this down, we have lithium metal, and then you start looking at lithium atoms, and you go into one atom, you see in this concentrated center are neutrons, which are neutral. They have no charge, but they do have mass, and protons. So the mass of the atom is made up from the neutrons, how many neutrons there are, and how many protons there are. And the electrons, we consider them negligible, so we don't consider the mass of them. The rapid moving electrons surround the nucleus and account for the large volume of the atom. So you can see electrons have a negative charge and protons have a positive charge, and neutrons have no charge at all. They're neutral. Electrical charges in an atom. Electrical charges is a fundamental property of protons and electrons. It's how chemical reactions occur and everything. Two of these charges were discovered due to the electrical charges. So positive charges will repel. Have you ever tried to put two magnets together? If they are the same sided, they will push each other off, and no matter how hard you try to put them together, you can't. And a negative charge will always be attracted to a positive charge. Unlike charges attract. If you put two negative charges together, the same thing will happen. So this is how we are using protons and electrons, as negative and positive charges. So an atom contains protons that have a positive charge, electrons that have a negative charge, and neutrons that have no charge at all. They're just neutral. They're there, but they play no part in it. Positive and negative charges cancel each other out. That's why you have to have the same number in an atom for it to be neutral, so that they pair off, and then they consider this charge neutral. They don't actually pair off to each other. They don't come together, but in the overall atom, there's enough positive charges on the inside and enough on the outside that it's neutral. So like charges repel and unlike charges attract. So when we add them together, if we have a positive one and a negative one, so this is one proton, one electron, we have an overall balance of 0 in it's neutrally charged. So if a proton had the mass of a baseball field, an electron would have a mass of a rice grain. So when we try to compare sizes, that's how big a proton is in compared to what an electron is. That's why we don't consider the weight, the mass of an electron. You can see here, it's pretty much very negligible compared to the mass of a proton and a neutron. So we consider this mass as 1.0073, 1.0087, and we use atomic mass units. We'll cover that later. Protons and neutrons have very similar masses. Electrons have almost negligible mass, which is why we don't consider them at all when we look at the mass of an element. So which of the following subatomic particles, subatomic means inside the atom, fits each of the descriptions below? Protons, neutrons, or electrons. Found outside the nucleus, that would be electrons. Have a positive charge, that would be protons. Have mass but no charge, that would be neutrons. So electrical storm provides evidence of charge of matter. Up in the clouds, you start having a negative charge buildup, and the bottom you'll have a positive charge buildup, and then you'll get this really pretty but scary if you're near it, lightning storm. So matter is normally charge neutral, having equal number of positive and negative charges that exactly cancel out. But an electrical storm, that doesn't happen, and that's when you start seeing things like this. It does this to try to actually get it back into being charge neutral. That's it.